Okay, so welcome to my short video on the right-hand rule. There are a lot of other videos on the internet. However, I'm shooting this one in POV because I think that is the easiest way to learn the right-hand rule. So I'm going to be using my right hand. Um, I know there's a lot of this way on the right-hand rule, and it's very confusing. Myself personally, I must have had my professors, TAs, friends go over the right hand rule at least 30 times before I finally found a process that I thought was much simpler to explain and learn how. And the feedback I've gotten during my TAing and teaching career has um, reinforce those opinions, I guess, personal opinions. So first things first, let's just talk about what is a cross product. When do we need the right hand rule? We need the right hand rule when we're doing a cross product, which is between two vectors. So A cross B, and the magnitude of the result of that is going to be magnitude of A times magnitude of B times sine of the angle in between. You're going to hear me just refer to this as 1 cross 2, vector 1, vector 2. So I wrote the formula both ways. Quick note, so whenever we do a cross product between two vectors, the resultant vector, so in this case 1 cross 2, vector 1 cross vector 2, is going to result in vector 3. Vector 3 has to be perpendicular to both vector 1 and vector 2. So as a quick example, if this is vector 1, this is vector 2, well, we know that vector 3, the resultant is either going to be into the page or out of the page, and we have to use the right-hand rule to figure that out. These are two very common formulas for physics 2 and magnetism. Magnetic force, what is the magnetic force due to a moving charge or a current carrying wire? And we have to know the cross product with these because we will use the formula to get the magnitude, but we have to get the cross product correct in order to get the direction. And so first, I will say, because I'm sure there's people saying, well, there's multiple cross products or there's multiple right hand rules, and you're not wrong. The first one is fairly simple. So if we have a current carrying wire right here at the top, right, we just point our thumb in the direction of the current, which is straight up. And what that tells us is on this side, the magnetic field is going to be coming out of the page. And on this side, the magnetic field will be into the page. And we note into the page with an X and out of the page with a dot with a circle around it. I'll talk more about that later. My recommendations when you have to do the right hand rule, draw vector 1 and then draw vector 2 right next to it. It's going to make your life a lot easier. We are going to cover um, different different types of examples, but let's start with just an easy one. So right here, vector 1 cross vector 2. So I'm going to give you two different ways to do this right-hand rule. It's the same, but sometimes explaining things in multiple ways can make it click for one individual and not another. So the way I first started doing this is vector 1, whatever direction vector 1 is, I take my right hand. So in this case, vector 1, and my fingertips are going to point in the same direction as vector 1, right? So right now, my fingers are pointing in the direction of vector 1. My thumb is going to stay out to the side like that, right? So vector 1, that's all I have to do, fingers pointing in the same direction as vector 1. Now my palm needs to face vector 2. Well, vector 2 is pointing to the right. So now my fingers still pointing up with vector 1. My thumb is still pointing into the page right now. It's still straight up, as you can see. So vector 1, and then you can check and confirm, right? Because my palm needs to face vector 2, but my fingers need to curl to vector 2, right? So if I'm doing this right, my first finger should be pointing in the direction of vector 1, and the rest of my fingers, other than my thumb, should be pointing in the direction of vector 2. And what that'll do is it'll give us the resultant vector will be our thumb, the direction. So we're going to have into the page as vector 3. Again, fingertips pointed up, thumb out, palm facing second vector, and then to check, you can just curl your fingers and they should be covering it. And this is actually the right hand rule that they teach normally is do vector this, vector this. But for me, I think it's much easier. Vector 1, fingertips in the same direction of the arrow, and then all you have to do is face your palm towards the second vector, and your thumb will tell you the direction. So you can see my thumb is pointing into the page. And if you consider this page as the X and Y plane, right, then the third direction is Z. So, all right, cool. We did it for 1. And again, I highly, highly, highly recommend when you're first doing this, rotate your finger, right? Rotate your paper. So I like to draw my coordinate system, draw vector 1, vector 2. All right. So for this second example, you saw me, I just rotated my paper, but I have my coordinate system, so I can always go back. Now, again, I'm going to point my fingers palm down, but if you're comfortable with it, right, you can point your fingers in the direction of the first vector and your palm in the direction of the second vector, right? You could do that. But if you're still getting used to it, palm down on the first vector with your fingers pointing in the same direction and your thumb pointing out like so. And then from here, again, all we're going to do is our palm needs to face the second vector. And then now if I want to check and confirm, right, I should be covering the two vectors. And if you notice, right, I'm covering it, thumb is coming out of the page. So I can literally just rotate this back and say, okay, it's coming out of the page. So the result here is going to be in the positive Z direction, which is out of the page. All right, let's do a couple more examples. This time I'm going to make them a little bit more difficult, right? Because example number 2 here, this is a common physics 2 problem or physics electromagnetic magnetism course introduction. So first off, out of the page is going to be the dot in a circle. Into the page is going to be an X in the circle. The way I was taught to think about it, and it does seem useful, is think about the arrow tip, an arrow pointing towards you or away from you, right? So if you're looking this way, you're going to just see a dot coming towards you, which means the arrow is coming out of the page, right? If you're looking at it this way, right, you're going to see an X because the arrow is going away from you. So you would see the feathers on the arrow going away from you. So that's where in the page, out of the page comes from. But again, if you are not comfortable with this, then I recommend drawing your coordinate system, and you can even draw the directions, right? So this is plus y, this is going to be plus z. So I already know based on the definition that our resultant vector is either going to be positive or negative x direction, right? Has to be perpendicular to both z and y. And so if you want to see what this actually looks like, right, is we're adding a vector y to vector z, which would be my pencil right now, right? However, the approach I just taught you still works. So fingertips in the direction of the first vector, right? It's vector 1 cross vector 2. So vector 1 is in the positive y direction. Now, how do I point my palm towards vector 2 coming out of the page? Well, very easy. My palm just points out of the page, right? So if I were, again, to check, right, y is covered by my index finger. And if my pencil was still standing up and you looked from the side, right, my fingers are going in the same direction. So the resultant vector here is going to be in the positive x direction. All right. I will say it's important to look right here. If Q is negative, you can either use your left hand, which I don't like, or just put a negative in front of the right hand rule. So it'll be the opposite. If you have a negative charge, it's going to be the opposite of what the right hand rule. You can try to do the left hand rule, but to me, that's just super confusing. Okay. So this is a problem. Sometimes it's given in physics 2, where you have a moving charge Q and it's moving into a uniform magnetic field, and they want to know what's the magnitude and the direction of the magnetic force, right? So again, this is one where I'm literally going to rotate my paper, especially if you have things in the negative y direction. Again, for me, it's just much simpler to rotate my paper because we already know. So looking at this one, right, we have an x direction and we have a z direction. So that means my result needs to be positive or negative y. But let's go ahead and test and see if my method works. Okay, palm down, fingers in the direction of the first one. Now my palm needs to face the direction of the second vector, right? So the second vector is like this, right? In this direction, positive z. So palm down, my fingers need to curl towards the second vector, right? And so if you notice this, right, my index is in the direction of vector 1. My fingers are in the direction of vector 2, and my thumb is telling me the direction of the resultant vector, right? So we know that the resultant vector is that way. Come back up here. We know it's negative y. All right. And I'm going to show you one more just to show you into the page. Pretty straightforward. So if you're looking, right, this vector is going through the page, down, under the table, into the table. So again, 1 cross 2. So vector 1, my thumb is out, and my palm is face down. Now, the nice thing about this one, right, is that vector is going into the page. My palm is facing into the page, right? So if I go like this, well, my index finger matches up perfectly. My fingers match up perfectly, right? The rest of my fingers, they're going into the page. So that tells me, based on my thumb, right, this one is going to be in the negative x direction. So now let's do number 2 one more time, but this time let's make it negative q, just so you can be aware, because this is a huge thing. Okay, so V cross B, that's our formula for force. So V coming out of the page, okay, index fingers going in the direction of vector 1. My other fingers are coming out of the page vector 2. My thumb is telling me this is going this way, right? That's from the right hand rule. So now we turn here and we say, okay, this would be the negative y direction, right? But remember what I said earlier, if we have a negative Q, you can just put a negative in front of the right-hand rule. So right-hand rule says down, but Q is negative. It's an electron, let's say. So the negative right-hand rule, right? And we said that the right-hand rule is negative Y. So we have negative, negative Y. So for example 2, if Q is negative, our resultant vector from the cross product will be in the positive Y direction. If Q is positive, it'll be in the negative Y direction, right? So I know this is confusing. This arrow, that's not a vector. That's just me pointing to the problem. So again, quick recap. Fingers down, pointing in the same direction as vector 1. Palm facing vector 2. And if you do it right, it should cover it up. These fingers should go in vector 2, your index should go in vector 1, and your thumb tells you the resultant. And this is actually what they try to teach us in class. I just found that this explanation was much easier for myself and for some of the students that I taught. So thank you so much. Hopefully this helped you. Feel free to comment with any feedback. Good luck in your courses and your semester.